Three frontier models launched in the same week. GPT 5.6 from OpenAI, Grok 4.5 from xAI, Muse Spark 1.1 from an emerging competitor. The internet did what it always does, declared winners, picked sides, ran benchmarks. But the real story wasn't on the leaderboard. The real story is that the gap between these models has collapsed to almost nothing. On reasoning benchmarks, code generation, multimodal tasks, the differences are now rounding errors. And when capability converges like this, the strategic question flips entirely. It's no longer which model is best. It's which model is best for this specific request at this price right now. That shift changes everything about how production AI gets built. Here's the economics. A frontier API call from OpenAI or Anthropic can cost 10 to 50 times more than an equivalent call to an open-weight model like DeepSeek v3 or GLM-4. For a company processing millions of requests daily, that isn't a rounding error. It's the difference between a viable business and burning cash. But not every request needs frontier intelligence. A customer service summary doesn't require the same model that debugs distributed systems code. A translation task doesn't need the same reasoning engine that analyzes legal contracts. The insight is simple. The implementation is not. This is where routing enters the picture. Platforms like OpenRouter have built infrastructure that sits between your application and dozens of model providers. You send a request, the router evaluates complexity, cost constraints, latency requirements, and capability needs, then directs that request to the optimal model. OpenRouter recently raised over $100 million, reportedly at a valuation exceeding $1 billion. Investors aren't betting on any single model winning. They're betting that the switching layer, the intelligence that decides which model handles which task, becomes the most valuable piece of the stack. It's the AWS thesis applied to AI inference. Don't pick a winner. Route traffic. The routing thesis only works because open and mid-tier models have gotten remarkably good. DeepSeek v3 and its successors match or exceed earlier GPT-4 class performance on many benchmarks at a fraction of the cost. Kimi from Moonshot AI has pushed long context performance into competitive territory. Zipu's GLM series offers strong multilingual capability. These aren't toys. They're production-grade models that handle 80% of typical workloads competently. The remaining 20%, complex reasoning chains, nuanced judgment calls, novel problem structures, that's where you route to frontier. Builders are converging on a practical decision framework. Think of it in tiers. Sol class calls, your highest tier, go to frontier models. These are for tasks where accuracy is non-negotiable. Medical reasoning, legal analysis, complex code generation, safety-critical decisions.
You pay premium prices because failure costs more. Terra class handles the capable middle ground. Summarization, structured data extraction, moderate code tasks. Strong open models handle these well. Luna class covers high-volume, low-complexity work. Classification, formatting, simple Q&A, routing decisions themselves. The cheapest models that meet a quality threshold win here. The art is drawing those boundaries correctly for your specific application. The numbers are striking. One AI startup, building a developer tools platform, reported cutting inference costs by roughly 85% after implementing intelligent routing. Their approach: send every request through a lightweight classifier first. Only 12% of calls actually needed frontier capability. For a company processing 5 million API calls daily, the difference between routing everything to a frontier model versus intelligent distribution can be $400,000 per month versus $60,000. At scale, routing isn't an optimization, it's a survival strategy. But routing introduces its own risks. Consistency becomes harder to guarantee when different requests hit different models. A user might get a brilliant response one moment and a mediocre one the next, not because the system failed, but because the router made a different cost-optimized choice. Data sovereignty matters too. Routing to Chinese-hosted models raise questions for enterprises handling sensitive information. DeepSeek's privacy practices operate under different regulatory frameworks than US-based providers. And there's a subtler problem: evaluation. When you're routing across 6 or 8 models, monitoring quality requires testing all of them continuously. The operational overhead is real. OpenRouter's raise signals something larger than one company's success. Venture capital is recognizing that the model layer is commoditizing. When GPT 5.6 and Grok 4.5 and a dozen open alternatives all cluster at the top, the defensible position shifts to orchestration. This mirrors historical patterns. Cloud computing commoditized servers. AWS won by routing and managing them. Twilio commoditized telecom, and won by abstracting the carrier layer. Stripe commoditized payments infrastructure. The bet is that AI inference follows the same arc. Models become interchangeable. The routing layer becomes essential. The convergence will only accelerate. More models from more providers with tighter capability gaps. The builders who win won't be those who pick the right model. They'll be those who build the smartest routing logic, who understand their own traffic patterns well enough to match every request with its optimal provider. The AI model war made for great headlines, but the real infrastructure story was always quieter, always more practical. It's not about which model is best.
It's about which model is best right now for this task at this price. That question, answered millions of times per second, is where the next generation of AI architecture lives.